Welcome, ladies and gentlemen, to another great episode of The Greatest Show, where Donald Trump approved, as I've said many, many times. And also, fun fact, before I get started on all the introductions, 84% of all statistics are made up. And with me, as always, is the other half of the sexy dynamic duo, Mr. Satan Fish himself, Jesse Daniel.
That is correct.
And if you're wondering who the sultry, high-pitched voice talk to you right now is, it's the one, the only, Phoenix King One, me! Ah! Joined with us, as always, is a very special guest that, first time, I've been trying to get him on for a while, but Mr. Amazing Superhero Dr. Powell.
Hello.
Also known as one of the coolest guys in the world next to Mark Evans. It's a tie. I don't know who I like better.
We're also joined by everyone's favorite time traveler, the man out of time. Doctor Who dropped him off in the 30s. He jumped back up.
He wasn't too, right? It's a tough subject for our good friend Tim. Mr. Tim Kelly, the time traveler.
That's right.
So how was the 30s?
Oh, very interesting.
Fun fact, he only is able to time travel from the year
1922.
No, it's the year 1900 to 1959. Anytime other than that, he doesn't want to and or is unable to.
Very true.
It's very difficult for us to get him on the show because we have to find him like in the time stream and then pull him back out. It's just a lot of work.
One of our producers, Austin, has helped us do it. It's just a pain in the butt.
Talking about our producer, Austin is here with us today.
Yes, hello.
So that's everyone who's going to be on the show today. And we're going to turn it over to Dr. Powell right now, who's going to tell us a bit about nanotechnology.
All right, nanotechnology, it's basically the science of things that are 100 nanometers or below. Now, to get a scale of that, imagine like the comparison of a large rope to the width of a human hair. So you get the large, thick rope and then really thin human hair. Now, if you can take that scale and imagine basically 1,000 to 10,000 times smaller the human hair, that would be on the nanoscale. That's when you're getting to things like DNA strands, proteins, and your nanoparticles and different nanomaterials that we're utilizing. So nanomaterials will basically between atomic level and 100 nanometers as far as size of a bulk material you already know. One of the things about nanotechnology is that when it goes down to that small size, it exhibits completely different properties from what it does for its bulk material. So for instance, gold, when it goes down to the nanometer size, it's no longer gold colored. It turns pink or purple. Another thing about nano gold is it absorbs infrared energy and heats up. They've utilized nano gold to try and do cancer treatments by basically heating up and basically cooking the cancer cells. One of the problems with that method on humans when you get into any deep tissue cancers is that infrared doesn't penetrate very far into the human body. Fun fact about nanotechnology, it's been around for thousands and thousands of years. They would take and add chemicals and acids to gold coins or silver coins, and they would create ink. And a lot of these inks you'll see in old cloth and such didn't really survive so much through the years, but like stained glass windows, ancient stained glass windows, when you get your yellows, your purples, your blues, pinks, those were all made basically utilizing what we call today nanotechnology.
Now, you mentioned how nanotech is being used in cancer treatments. What other kinds of uses are we putting nanotech to?
Well, current common nanotech you'll see in things such as sunscreens and other cosmetics for anti-aging agents. You'll see it in strengthening materials such as what we carbon fiber, making things lighter and stronger, kind of incorporating them into different materials. Also, some of the new things like your silver nanoparticle socks, where basically you can wear socks that don't stink because that stink you get in your shoes and socks comes from bacteria. So nano silver has long been used as an antibacterial agent, and some naturalists actually don't use your formal prescribed antibiotics. They'll take a bit of what you call colloidal silver, where you can find at like a naturalist or health store, and you can take that as an antibiotic.
So there's a lot of medical uses that we're putting nanotechnology to.
Yeah.
Any of the military R&D side?
Military, no, because military is usually pretty secretive. I do know for some of the side that's been incorporated into the military, they've been using conductive carbon nanotubes into films and coatings for de-icing the wings of planes. Trying to think what other applications for military. That's one of the main ones. Also for wound dressing and bleeding, they've been using a nano-based matrix to basically have this spray foam coating that has nanotechnology incorporated, where it will disinfect the wound, and then as the foam dries, it will close up and stop the bleeding.
What are some of the industrial uses that we're putting nanotechnology to?
Industrial uses are tough. For some of the uses, again, we're incorporating nanomaterials into textiles as anti-fouling, aka antibacterial agents. As far as actually enhancing some of the actual materials, such as the plastics and such, we're looking at incorporating carbon nanotubes and fullerenes to make them lighter yet stronger, trying to get a material that mimics the strength of metal, but has the lightness of your common polymer. One of the issues with nanotechnology is going from the research phase and how it acts in a small form to producing that into a bulk material that can be used commercially and in a manufacturing setting.
Nanotechnology is a very unique and interesting subject. We've posted a article about it on our Facebook page. So if you want to learn more about nanotechnology, check that out. Also, if you want to learn some more about nanotechnology, I believe they still have the nanotech class here at Athens Tech too.
Yes, we go over a lot of the potential applications, the basics of nanomaterials and nanotechnology, even the production and synthesis of nanomaterials.
I just want to know when I'm going to get my Iron Man suit that can form to the exact shape of my body. Just a bunch of nanobots joining together, kind of like Voltron. That's what I'm waiting for.
A bunch of nanobots forming together. It's a cool concept. However, there are a lot of control issues.
Yeah, I know it's
that.
completely unrealistic.
I think you should go more Big Hero 6 over.
See, that's what I thought. But
Iron
you know
Man.
what? He had the extremist suit that kind of did that, and I was like, you know what? I want that. that was cool. It's not going to happen anytime soon, but I mean, maybe one day. Maybe I inspire somebody. Like, you know what? I love Jared so much. I'm going to build him that suit, and I'm going to give it to him.
Are you trying to hint at something?
Yeah, Tim, do your job.
We're going to keep moving on. If you have any questions about nanotechnology, hit them up in the comments section, and we will be more than happy to bring Dr. Powell back on again to talk about nanotechnology some more. We're going to move along. Tim Kelly,
What's up, Timmy?
what do you have to talk to us about today?
I really don't know.
Oh my God, Tim! I've given you 3 days to prepare.
Well, Tim, you're looking to create your own robotics development firm.
Fun fact, also with yours truly.
Why don't you talk to us a little bit about some of the robotics technologies that you're interested in?
The main focus for our business would be to make any common household item and make it do whatever itself.
So
To
moving
make it completely
autonomous.
to make a completely autonomous thing. One of the things we're working on is like focusing on like medical side also. Well, I don't want to go exactly into like what project we're working on right now because we're still in a like heavy R&D stage on getting everything sorted out. But eventually, I want to be able to branch this out to where we can help out both like people that like are a part of Wounded Warrior because I have a lot of like military history in my family, and you know maybe even invent like a way to use technology to help with PTSD, injuries, things of that nature.
Can you give an example of autonomous appliances or whatever you're looking at?
Yeah, so there was a commercial that I saw from the late 50s, early 60s, and it was actually an oven that was built into the refrigerator, and the in the commercial, the woman actually called her oven and told her to put the turkey on, and it transferred the turkey over from the refrigerator to the oven and had it cooked by the time she had gotten home.
Wow.
Tim's a genius.
I'd invest in that.
Yeah. So you've mentioned automated appliances, medical sciences. What are some of the practical, everyday uses that you would put your technology to?
Well, we're working on like some basically lawn and garden projects, trying to make an autonomous lawnmower.
And of course, we're doing this with a budget. We would like to
Be able to build it. I think we've said about like material marketed MSRP around $100 to $300.
Yeah.
Something that's not insanely unreachable for the average person.
So not only versatile but economical as well.
Yes.
Well, I would be as bold as saying if our company actually does this right, within the next 3 to 4 years, we can have medical items that cost around $150.
That would be impressive.
And believe me, I am intelligent, but Tim is a genius. The way that Tim goes about looking at robotics is something I haven't seen in a very long time. Tim's imagined. I'm more like the creative side. Tim's the dude's like, hey, we can totally do this, and here's how. Tim's got the imagination and the know. That's why, like, for some reason, I've naturally gravitated. If you notice, like, whenever Tim's on, I make a lot of fun of Tim, but it's all in love. I love Tim to death. There's a reason I've decided to work with both you, Jesse, and Tim.
Now, robotics is another branch of engineering and sciences that's been around for thousands of years, like nanotechnology.
Mm-hmm.
What inspires you the most when talking about robotics?
Really, honestly, I guess to make the world better is we can always push ourselves forward, no matter what obstacle we have.
That was one of the first things Tim's ever said to me. And I was like, Tim, you're making me tear up, buddy. That's one thing that I've always enjoyed about working with Tim is that he may not be able to word it, and that's where I come in. But it's not a bad thing. That's why I love you. We every kind of shortcoming I have, Tim answers. Every shortcoming he has, I answer.
So when
symbiotic.
so when you're talking about specific robotics, and you're talking about things like medical devices. Now, are we talking about
prosthetics?
Yeah, we're talking about prosthetics here.
Maybe down the road, inventing an autonomous like robotic surgery unit. There's stuff out there that's like manually driven.
Yeah, they have the Da Vinci button, isn't it? In
Athens Regional.
Yeah. But that is a expensive machine, and to keep it up is just absolutely ungodly. I mean that hospital has got to make a lot of money.
So your goal is to make advanced technologies
that's
of an
practical.
affordable nature.
Yeah,
Yeah.
advanced technologies at a practical price.
Now that is a fantastic idea. We're going to put up an article on the Facebook page about robotics if you're interested in learning any more about it. Again, if you have any questions, hit us up in the comments, and we're going to be bringing Mr. Tim Kelly back again just as soon as we can get him out of the time slip. We're going to shift attention over to Austin here.
Yes, hello.
We don't really let Austin talk a lot, and we thought, well, me and Jesse were like, you know what? We're going to give the time to someone else. I'm going to let Austin talk for exactly 5 seconds, and then Jesse's going to violently interrupt him.
Now, Austin, you're a specialist as far as the other students here goes for 3D printing.
Isn't the 5 seconds
that's correct.
done?
Yeah, the 5 seconds is
Oh, okay.
over.
And so now, what we need, no, but in all seriousness, Austin, tell us about 3D printing and some of the uses that it's being put to today.
I've only been really 3D printing for about 7 months now, so I've only been on and off to doing it, but I've only been kept to printers that are using a PLA and an ABS filament, so just different kind of makeups for it that make it different.
Tell us some about the different filaments.
The PLA, I think the PLA was the one where it was it had to be heated up a little bit more, and it made it a lot more sturdy when it dried. The ABS is the one that is a little more brittle, easy to kind of break if anyone was needing to do it. So if someone was like putting or is trying to make like a nut and bolt, they want to use their PLA filament to make it a lot more sturdy, be able to do micro details in the object to where it can actually screw in with the bolt.
Now, tell us some about the process of 3D printing, about how it's actually done.
Just setting the printer up, you want to just pick your filament, making sure it's compatible with the printer so it doesn't go all nuts on you. It starts by preheating the extruder to about 215 degrees Celsius, so roughly 435 degrees Fahrenheit, I believe. It spits it out of an extruder that, well, the printer itself has a file put onto it to print out the object that you want. Doing that is an STL file. Anyone can make that on Blender, and that's actually being able to extend your imagination on just building what you want.
Now, when you say Blender, you mean the 3D modeling
Yes.
software and not an
software.
actual Blender.
Yeah, don't use that Blender. 'Cause that's just going to be a mess.
Oh my God.
I've tried it. It's really nasty.
The printer takes the file and it spits it out on a plate. And the filament is heated. It's 400 degrees Fahrenheit coming out of the extruder, but it dries very quickly, where in about 3 seconds you can just pick it off the plate then and there.
And now it builds it in layers.
Correct.
What are some of the other uses that we're putting 3D printing to?
More modern uses for that is with food. Like with cake decoration, people are using 3D printers to make massive detailed cakes to where it looks like an abstract object or one of the little puzzles that you would see back in high school or whatnot. Just made of eraser.
Now we've read in some articles that there are medical aspects to 3D printing as well.
Right. I had somebody come to me just this past week with a broken neck cradle for one of the mannequins and wanted me to 3D print one if I could. I told him, yeah, it's very possible because we have a scanner that we would just scan around the neck cradle and it would take the entire object, fill in the crack that was on the neck cradle, and it would print out a brand new one that was as sturdy, if not more sturdy, than the neck cradle itself.
Now I know they're using 3D printing to make replacements of like noses and ears,
Right.
skin grafts for burn victims. What are the possibilities of bone grafts?
Bone grafts would, I I think the filament itself would have to be made out of a marrow. If they were just going to prosthetics, then it'd be made out of metal or a more sturdy plastic like the PLA. That wouldn't be too difficult, but replacing a bone itself, you would have to go in with the more biological aspect with it.
Now, I've always wondered about this. What are the likelihood of, and anyone else can feel free to answer in on this as well. What are the likelihood of being able to 3D print viable organs for organ transplant using skin cells?
I don't think the tech's there quite yet because I don't know if we're at the stage in which we can do organic printing.
There's actually testing for it. They were actually trying to 3D print a nose, an ear. I think they were 3D printing lips.
The setback is that you've got the stem cells that have the ability to change to an organ, specific organ cell, and the problem is the signaling the cells to reproduce and create that specific structure, and then signaling it to stop producing. So there's this huge study called proteomics, which is the study of how proteins basically communicate with each other. So going into a little bit of biology, all your functions are pretty much governed by proteins. You got messenger proteins, transfer proteins, all these different proteins that regulate send signals and such. And so scientists are still trying to find out what that signaling process is and pretty much the protein language to be able to directly build like a liver or a kidney. We can give the cells like a certain scaffold or matrix and hope for it to like keep building that, but the stability of the structure just isn't there yet.
And again, if you have any questions about 3D printing, hit us up in the comments. We're gonna try to post a article on 3D printing on the Facebook page. So give us a like and subscribe to our YouTube channel. If you enjoyed what we had to talk about today, give us a like on the Facebook page and be sure to read those articles. That's all the time we have for today. Make sure to tune in for our next episode. We haven't
Wednesday or Monday.
Yeah. And have a great day, guys.
God bless.
Bye.
Later.